Here I will introduce 4 cases of warm settled score lines respectively. Case 1. This was a warm settled score line process in April 2016. We should pay attention to 3 aspects. First, the score line's moving direction was obviously different from that of the frontal score line. The frontal score line moved from northwest to southeast, while here, this score line was moving from west to east. The second was that the 3 score lines affected the north, central, and south of Guangxi in sections. The first and the second score line lasted about 8 to 9 hours, and the third score line spent about 5 hours on passing through the southern Guangxi with a fast moving speed of 70 to 80 kilometers per hour. The third was that all the score lines moved into Guangxi and developed eastward after being tricked outside the mainland. This is the evolution of composite refractive radar echo profile greater than 35 dBz. The first score line is a short score line, or call it bow echo. It was a linear convection with a looser structure when it moved eastward into northwest Guangxi at 18 April 21st. From 8 p.m. to 9 p.m., the score line gradually evolved into the north-south direction. The refractive increased. The echo structure became dense, and in the north of the score line there were echoes generating from the back to the front. And from 10 p.m. to 11 p.m., the bow echo range became larger and wider. The portrait to the northeast, the rear inflow obviously intensity, and then the ground wind reaches the maximum. And then the north both echo weakened and became looser, while the southern echo gradually weakened and at last disappeared as it moved eastward. And the second score line, when the first score line moved to the central part of Guangxi, it was tricked in Yunnan as a south-north linear convection. 1 hour after entering Guangxi, the linear convection evolved into the prototype of score line. There was already rear inflow behind the leading convection line. Although the echo intensity at this time was still relatively weak, but the ground wind began in the most prominent bulk, the position having the strongest echo. And then the scoreline developed into a long scoreline with a length of about 250 kilometers in the north to south direction, with a ratio greater than 5:1, which was the most vigorous stages of the development of the scoreline. And the rear inflow was significantly increased with the leading convection line and trailing stratiform cloud at the rear, and the echo developed strongly in the backward direction. In front of the largest back echo reflectance factor, strong wind and short-time heavy rainfall occurred. The scoreline lasted for up to 4 hours and caused a wide range of thunderstorm gale and short-time heavy rainfall in central Guangxi. After 3 a.m. the next day, the echo moved eastwards and weakened. Here's the distribution of gale and thunderstorm was about to weaken from the warm another convection process was triggered in North Vietnam and then influenced North Guangxi. Statistics show that was a short strong wind appears with a length of about 100 kilometers. This process has no obvious characteristic echo appeared. More gale, but it still brought gale and thunderstorm weather. The second to the coastal areas of the most severe convection weather during the impact period. From composite reflectivity and storm tracking information of the scoreline in the vigorous phases of the development. From the radar echo evolution of nearly 1 hour, we can see that the scoreline was approaching Nanning City radar station, and the rear inflow intensified with trailing stratiform clouds. The leading convective line strengthened against and was very close to the scoreline, almost parallel to the scoreline. This was because there were new cells developing in the front of the scoreline, and at the end of the scoreline, there were also new cells moving and developing eastward. From the storm tracking information, it can be seen that the convective cells moved in the northeast direction. That is, the strong echo moved in the northeast direction. And this is the time evolution cross-section of Nanning radar echo along the direction of 315 degrees. It has the following characteristics. First, the strong echo center reaches more than 7 kilometers and over -20 degrees Celsius high, accompanied by thunderstorm, and then center high dropped with time. After touchdown, gale appeared on the ground. And the second, in the basic velocity diagram, the large wind speed area also dropped with time. and approached the radar station, indicating a large range of large wind speed area, which was the result of the cold dry air after the upper trough. This is the evolution of surface front from 20 o'clock on April 21st to 8 o'clock on April 22nd. The surface stationary front weakened and the warm low pressure developed. Among the scoreline developed, there is no cold air invade to Guangxi. Before the convection occurred, there is an upper trough in the northwest Guangxi. By 8 o'clock the next morning, the trough had moved eastward. It can be seen from the temperature. There is an obvious temperature trough at the back of the high trough, and the intrusion of dry cold air in the middle layer is conducive to the evaporation and cooling of precipitation partial in the descending process, and to the strengthening of the downdraft as well. This is the T-log chart before the severe convection trick. Figure A and B are of sounding in north of Guangxi, and C and D are soundings in south of Guangxi. We can see from the figures that temperature and humidity stratification profile of the south soundings had a structure of upper dry and lower wet. The temperature below 800 million bar was almost saturated, while the difference between temperature and dew point temperature above 800 million bar began to increase and became dry. The temperature difference between 850 million bar to 500 million bar in south of Guangxi was 25 to 26 degrees Celsius, and Cape of Southern soundings was much higher than that of northern soundings. Almost the vertical wind shear 3 kilometers was greater in the north than in the south, and the lift condensation level was very low, about 925 million bar below. In conclusion, environmental conditions in the south were favorable for the development of deep convection. And this is a photograph of 5 sounding stations in Guangxi. In the low layer of south of Guangxi, lower than 3 kilometers, it had a large vertical wind shear vector, will rise with high. showing a clockwise rotation from the lower layer to the middle layer, resulting in the intensification cyclonic rotation storm. This is the warm score line summary. The warm sector score line occurred in the early stage of the development of low pressure. Convection was thick before the upper trough, followed by a cold trough. There was unstable stratification with upper dry and lower wet. Low-level wind vector difference was large, and the hodograph clockwise rotated with hay. And the real score line model featured the leading convective line and the trailing stratiform crown. That's all for this part.